Or we could just watch the sun explode. That could be fun too. Oh, that's actually quite beautiful. Yeah, if you're gonna die, that's the way to go. In a beautiful supernova that really, it takes you out before you even know you're gone. Hello everyone and welcome back to Astrophysicist Plays Outer Wilds. I'm excited to get back into the game here. So, once we get back in, we can go to the ship's computer to catch up on exactly where we are with all the various clues. But to give you a brief recap, last time we started exploring Brittle Hollow, checked out the gravity cannon, quantum tower, and we're able to make our way to the Southern Observatory with a bit of difficulty. And this time, I'm thinking we'll check out the Hanging City, which is the last major location, at least that I know of, left to see there. So we've got a bunch to catch up on the computer here. And we can just check here if it gives us any other leads that we should be looking at. Okay, yeah, it's been a bit since we checked the computer, so it's filling in quite a bit. Okay, yeah, let's look like there's a big cluster of quantum stuff there. We'll have to do that at some point. Okay, so let's see. Let's start off with the Brittle Hollow stuff. So I think this is Giant's Deep. Oh, yeah, we do have a bit to read up on here. So the Bramble Island, we went there as well. An island of thorny vines and what appears to be a frozen jellyfish. It looks like Feldspar camped here before heading off to Dark Bramble. Okay, and then that leads us to about Feldspar. Feldspar headed to Dark Bramble. And then, yeah, we've seen all of that. Okay, Rybeck's camp on Brittle Hollow. So I guess the gray is maybe the other Harthians and what they've been doing. Okay. Rybeck has set up camp at the bottom of the crossroads. Yeah, that's kind of a central point in Brittle Hollow, where I think Rybeck's camp is the most notable location. Rybeck, their excitement at being surrounded by so much Nomai history is matched only by their terror of the black hole. Rybeck is Timberhearth's only archaeologist. They overcome their fear of space to explore Brittle Hollow's treasure trove of Nomai culture. Okay. Oh, they overcame. Yeah, that's it. Okay. So... Okay, yeah, so it shows the Southern Observatory here, which I guess does relate to Giant's Deep, so we can read it here. Yeah. The new, more sensitive locator the Nomai built in this observatory was unable to detect any trace of the eye's signal. Based on their knowledge of the quantum moon, the Nomai believed the eye was in a distant orbit around the sun. The Nomai decided to stop searching for the eye signal and instead look for it visually by sending out a deep space probe. There were concerns that the probability of launching a probe in the correct direction would be absurdly small. Tornado simulation. Most cyclones on Giant's Deep rotate clockwise. These are the cyclones the Nomai used to send components into orbit. They used to send components into orbit, not they used to send. Yeah. There also exists a rarer type of cyclone that spins the opposite direction and pushes objects beneath the waters and below the current. So you might remember me raging about that cyclone, saying that it makes no sense from a Coriolis force perspective for it to exist, but presuming it does, and these cyclones also work in the way that the way they blow things relates to which way they rotate. I guess it does make sense that they rotate one way, they blow things up, you reverse the rotation, you blow things down. So, maybe not so much to complain about there. Okay. So, Ash Twin Project. I'm not really seeing Brittle Hollow. So, I wonder how things are categorized here. So, map mode, so, let's see, if we go to the Brittle Hollow, okay, so they are, okay, I guess you can categorize them a couple different ways. Okay, Escape Pod 1, ooh, Okay, so there is more to explore by that escape pod. Shelter site. The Nomai survivors who crashed on Brittle Hollow climbed down the cliff to a shelter site below the surface. So it could be that when the platforms collapsed below me there, I missed something notable. So I might need to go back. Rybek's camp, we've seen everything. Hanging City, we haven't fully explored. Okay, Tower of Quantum Knowledge. Let's read this. So, the Nomai built a shrine on the Quantum Moon to aid in the pilgrimage to its 6th location. Remember this final rule. To explore the 6th location, the shrine must be on the moon's north pole. The pilgrimage to the Quantum Moon was a deeply significant journey for the Nomai. After the two groups of Nomai stranded on Ember Twin and Brittle Hollow were reunited, it became their united goal to find and visit the Quantum Moon. So it sounds like their biggest settlements were on Ember Twin and Brittle Hollow, so it might be nice to visit Ember Twin, see their other big settlement. Quantum Shard. A strange rock shard that wanders where no one is watching. The Nomai determined this shard is the reason objects in this grove behave in a quantum manner. The Nomai hypothesized that this shard is actually a piece of the Quantum Moon. This shard emits the same signal as the Quantum Moon. So, maybe we could use that signal if and when we want to track down the Quantum Moon. Gravity Cannon. A huge cylindrical structure that generates a strong upward gravity field. I recalled a Nomai shuttle from the Quantum Moon. Northern Glacier. The North Pole of Brittle Hollow is covered in snow and ice. There is a uniquely shaped Nomai ruin on the surface. The Nomai were able to warp here from their Whitehole station. This is where they first recreated warp technology. So you might remember I found a projection pool and wall there, but no tablet to use with it. Spent a while searching for it, and my suspicion is that we can find that tablet in the Hanging City, which it seems to be just below this northern glacier. Black Hole Forge, okay, yeah, so that's part of the Hanging City, which I didn't go to visit. Yeah, let's go back to rumor mode. I like that a bit better. Okay, so what else do we have around here? Whitehole Station. Every Nomai warp tower is tuned to a specific astral body. To use a tower, you must be staying on the warp platform during the tower's alignment with its corresponding astral body. The alignment happens when the astral body is directly ahead, and there's more to explore here. Okay, I must have missed something. Maybe you have to successfully trigger the teleport for that to register. Okay, so this appears to be all the quantum stuff. Ooh, some quantum signals. The Nomai detected a quantum signal coming from somewhere in Giant's Deep. We've already been there. I didn't see anything like that. Maybe we should go back. Yeah, now that we have the signal, we can maybe trace that down. The Nomai detected a quantum signal coming from somewhere on Timber Hearth. Huh, okay. We can look for that too. And Nomai detected a quantum signal coming from somewhere on the Hourglass Twins. Okay, we haven't been there. We're not missing anything. Okay, so Quantum Moon. The Nomai on Brittle Hollow observed a phantom moon that would sometimes appear in the sky. A Nomai named Solanum landed a shuttle on the Quantum Moon. Quantum Shrine. The Nomai built a shrine on the Quantum Moon to aid in the pilgrimage to its 6th location. I wonder how a shrine helps you aid in a pilgrimage. It's like a... But... Wait, no, they said the shrine has to be on the North Pole to explore the 6th location, which implies the shrine moves. That's odd for a shrine to do. Maybe it must be the quantum weirdness they're doing. 6th location. Many Nomai went on a pilgrimage during which the Quantum Moon carried them to its 6th and most secret location. To explore the 6th location, the shrine on the Quantum Moon must be on the moon's north pole. A Nomai named Solanum landed her shuttle at the Quantum Moon's south pole and prepared to make the rest of the journey on foot. Visitors to the Quantum Moon always arrive at the South Pole for reasons unknown to the Nomai. More quantum weirdness. Okay. So yeah, plenty of more to explore notes. Oh, something more to read here. Ocean depth. Blah, blah, blah. Yeah, nothing really important there. Wait, Wait, Feldspar found a way to reach the core of Giant's Deep. So we have found out how to get through the current. But it says Feldspar's found something and there's still the question mark. So maybe we should talk with him as well. Okay. So right now, before going on to Brittle Hollow, I feel like it would be nice to tick off exploration on Timber Hearth and Giant's Deep. So I think what I'm going to do is actually track down some quantum signals on these two planets and see if we can find where they're coming from. So the closest one will be the one on Timber Hearth. Yeah, it's hard to figure out which way. What's that? Hold on. Yeah, there's some sort of crater, a couple of craters that I don't think I've explored. Yeah, this doesn't look familiar. Yeah, let's try to make a landing here, see what there is, and maybe get a better idea on where the signal is on foot. Okay. So, signal scope out, quantum fluctuations. Okay, there we go. It's basically this way, 139 meters. We might be able to make that on foot. And there's also this structure here. So let's head up and see what's up here first. Then we'll head after that, those quantum signals. You know, it's interesting, I say see what's up here, assuming there must be something. If this were just the real world, there would be no reason to assume there's anything interesting here, but I'm kind of going by, well, I assume the game designers wouldn't put something interesting here without something more interesting to find if you go search it out. And here, something to read. Okay. Chert's research notes, property of Chert. I've detected a strange signal coming from somewhere within the grove in this crater. It's very similar to the signal emitted by the quantum moon. Yeah, so we are on the track of the quantum signals. So it stands to reason that two signals are probably related. We don't know much about the quantum moon, seeing as no one's ever been able to land on it, but hopefully, I wonder why they have trouble landing on it. I'll need to try that out myself, see what happens. But hopefully studying the signal in the grove will reveal more about it. Okay. So, signal scope back out, and yeah, signal's off this way. So this seems to be the grove Chert was referring to. Might be a bit tricky getting back to the ship, but worst case scenario, we can always meditate, restart the loop. Okay, yes. There's something quantum. Signal identified, grove shard. Okay, so that's what's causing this signal. You know, it's interesting. It's a nice singing sound from these. It's really quite pleasant. Okay, and then, yeah, like other quantum objects, it jumps around whenever you look away. And, in fact, it always jumps around. It never decides to stay in the same place. It always finds a different... Wait, what's that? Okay. Those signs appeared. I am not gonna let them out of my sight because they might disappear again. Okay. Across old bark in the ancient glade, it's always dark, the quiet shade. Huh. Okay, so this is one of the Harthians must have put this up here. And we've got arrows going left, right, left, right. Are they pointing to something, or maybe they only point when they're lined up the right way? So let's try, let's see. If we go, yeah, it might have to be in the right place to make sense. The quiet shade, it's always dark across old bark in the ancient glade. So it's a different order now. So I guess it's kind of a quantum poem, which is a clever idea. When you've got things that swap around, you set up the different pieces there, and you get a different order of words every time you look at it. Yeah, didn't quite... Okay, now it's away. Where is it now? What's the poem say this time? In the ancient glade, across old bark, the quiet shade, it's always dark. I really like this idea for a poem. It's something that appears different every time you look at it, and maybe everyone who sees it reads a different poem. Now that's art. Okay, well, I'm not seeing anything up here obvious to interact with, but there is this geyser, and as we found out in a previous episode, there is... Okay, that could be an easy way to get back out. But right now, I actually want to go down, see if there's anything interesting inside the geyser. Okay, I'm gonna need to wait a bit. Okay, then just after it fires, yeah, my legs are taking a beating. Then just after it goes off, I'll hop in. Almost, come on, come on. Okay, we'll quickly go in and then see if we can like get off to the side of it. There we go. Okay, so anything interesting around here? I see one cave. Yeah, I'm gonna put this signal scope away now. Okay. And where does this take us? Oh yeah, we've been here before, so I guess all the geysers take us to the same place. Ooh, yeah, and then we come out somewhere. I'm not really sure where. Oh yeah, we're far away from the ship now, aren't we? Well, yeah, okay. So, I'm just gonna meditate till the next loop, and then head off to Giant's Deep. So, I will meet you back there. Okay, and here we are arriving at Giant's Deep. Let's take out our signal scope, go for quantum fluctuations, and see where on the planet. Okay. 2 kilometers off that way, so yeah, that's probably still on the planet. Yeah, we're gonna be upside down, though. Oh, it automatically rights ourselves, so... ooh. Okay, ooh. It's leading us straight into that huge cyclone, which... That one's rotating clockwise. That's one of the... Clockwise is the throw you up type. So... How do we get inside? Well... Can we... Let's see. Oh, I've lost my view here. Yeah, I think I've just got thrown up by it. Oh, we are inside it in the eye of the storm, and there's a tower. Okay, so I get maybe this is another quantum tower. Okay, well, let's explore. There we go. Okay. So, quantum signals. That's a tower shard we saw before. Where's the close one? 121, so right in here. Okay. I'm gonna turn that off just so I'm not too distracted by it and actually look around a little bit. So... Is there anything we can do down here? Okay. No, doesn't seem to be anything interactable there. And can we get up out that hole? No, gravity is too strong on this planet for us to get any upward mobility. What else is there to do here? Is this anything? Just a broken off light, okay. Let's explore a bit more of the island then. Maybe there's some other way. Oh, yep, there's a ramp up. Okay. Alright, this will hopefully let us get in or lead to something. Okay, so I think it's interesting design. The ramp cuts through the tower. So maybe there was like a pre-existing rock formation here that they built the tower into to save on building costs. Okay. What does this say? Be welcomed in this place. This tower shares with all who ask the knowledge needed to make his or her first quantum journey. Oh, his or her. That doesn't really cover Hearthians. That's too bad. Well, alright. We tried. It's not welcoming to us non-binary Hearthians, but you know what? Screw you and your gender binary. I'm going in anyway. Ooh, this is quite tall. Okay. Entered this place without friends, however. These are lessons to learn for yourself. Huh. Interesting. Okay, so... what do we have here? Just, decorative plants. Looking at these, I wonder if this... So, are these buckets, like, originally they had small plants in here, which grew larger over time? Maybe... Oh, yes, definitely. You see, down here, it broke through the side. So it definitely wasn't meant to hold a plant of this side. It just got too big and broke out. Now, it's unclear if they were meant to hold plants at all, but given how many of them have trees, I suspect that they were intended for plants, just not this large. They just were left unattended for so long that they broke out of their pots. Okay, well, yeah, nothing else to do there. Just, okay, well, did we jump down? I think that was the same symbol we saw on the bottom. Looking at that, I wonder if there's any specific meaning there or way to decode it, or if it was just a design that I thought was cool. Maybe it's like their word for quantum stuff. Okay, well, here we go. And, it seemed to catch us for a gentle landing, too. Oh, and these trees are still living, so we get some oxygen. That's nice. Alright. Seek the Wandering Arch. Okay, one. Oh, there's the arch. There isn't the arch. Okay, there it is. So this arch is quantum 2, so we can't let it out of our sight. Yeah. Okay. There we go. I really should have looked before I leapt there. I would be way too vulnerable to someone setting up a trap. Unidentified signal. So, okay, signal identified, island shard. So they built this tower around this shard to take advantage of its quantum weirdness. But I wonder why it only affects some components of the tower, like the arches. Yeah, I don't know. Okay. Anything else? Just the shard. Oh, and the tree is wandering too. Does the hole up wander? No, the hole up doesn't wander. That's interesting, because it did wander when I was looking from the other side. Huh, okay. Down. Alright, what do we have here? Observing a quantum object. Observing an image of a quantum object. These are the same. Okay, so what do we need to do here? That's the same one. Yeah, this is trippy. Everything's moving. So we need to get to the arch. But yeah, now it's out of sight. And it's there. Can I make it come back by turning away? No. Huh. Well, I haven't seen where it is now yet. So maybe I have to look over here. Okay, there it is. It's across the way. And if I turn away, it's gone. And then over here, it's nowhere again. And it's nowhere again. That's weird. Why? There are only 4 possible places for it. Wait, is it 4? So, let's see. We've got 1. Oh, yeah, how am I going to keep track? Oh, look at the floor design. It's a hexagonal design, so there are 6 possible places it could end up. Oh, same post. Okay, so I saw it over here, but it's going to be gone now. And from here, there are really only 2 accessible spots. And yeah, if it goes across the way, I can see it and cause it to move. But there are still going to be a couple other spots I can't see it at all. So, what did this say again? Observing a quantum object, observing an image of a quantum object. These are the same. Okay, well, I do have a camera. So, if I take a snapshot there and keep the snapshot, yes, that does hold it in place. Okay. So, real-world science time. Although there is some quantum weirdness with indeterminacy that, like, you can set up a quantum state where you don't know where it is until you look at it and observe it. So, what happens in reality is that it will be determined as soon as you take a picture, or as soon as a human looks at it. Well, actually, no, the picture's a bit complicated. It's, yeah, quantum stuff, even in reality, gets weird. But the picture here shows you where it was, and, oh, geez, I'm trying to think of a good way to explain exactly how things differ in reality. But I think the biggest difference is that once you've seen something in reality, it stops jumping around unless you do something to cause it to start jumping around again. In the game, it'll start jumping around as soon as you stop looking at it or stop looking at an image of it. So whether or not it's jumping around depends on whether or not you're looking at it. So in reality, so I guess the difference is that if you want to look at something in reality, that necessarily modifies it. So to observe something, you have to say, shine a light on it, the light bounces off of it and back at you. And this modifies it, so you can't look at something without modifying it in some way, even if it's just the slight pressure of the light. But if you're looking at, so in that sense, looking directly at something does kind of hold it in place in a quantum way, as you have to constantly interact with it, which means it can't do weird quantum things like quantum tunneling between times you look at it. Actually, I should pause so we don't waste time. But looking at an image of something doesn't do that. It just records the state that it was, and while you're looking at the image, the original thing isn't being affected by the light that you would be using to directly look at it. So, in reality, looking at an image of something would in no way hold it in place, whereas there are circumstances where directly looking at something, directly observing something, could hold it in place. You know, this is a good time for a physics break here. Okay, so let's say you've got a cup, and you put a particle into this cup. Now, let's say you put a particle in with enough energy to get up to this height. So the particle could, let's say you leave the particle in the cup and it can do whatever it wants, but the maximum energy it has can only get up to here. So when you come back to observe the particle later, it could be plausible to find it over here or over here, not moving because it would use all its energy to get up there, or it could be down here, moving a bit, or at the bottom, moving a lot. So any of those would be plausible in a classical physics scenario. What you wouldn't expect to find the particle up here, because then it would have to have negative energy, and you wouldn't expect to find it outside the cup. But, if it is outside the cup, it wouldn't have negative energy. It would be at a similar energy state to places that are allowed inside the cup. The reason you wouldn't expect to find it outside the cup is that at some time in the middle, it would either have to go up and out of the cup or break through the wall, either of which would require more energy than the particle has. But let's think of this from a quantum mechanical state. So let's say, similar to the cup, we have an energy potential that looks like this, and we have some particle with this amount of energy. Now, from the quantum mechanical point of view, everything is a wave. So we draw our particle as a wave contained between these two potentials. So what happens in quantum mechanics is that if you want to calculate the equation for this wave, depending on this potential, you get a peculiar result when you go through the calculations, that once you get to where the height of the particle's energy reaches the height of the potential, the wave doesn't go away. It rather turns into not a wave, but an exponential decay on either side. So the wave function is wave-ish in between, but it's a decay within these walls. And then as soon as it gets outside the walls, it turns into a wave again, albeit a lower energy wave. So I'm using a bit of artistic license here. The height really should correspond to the potential, but I'm drawing it as a wave to illustrate more that it's a wave nature. What's really going on is more that the amplitude of the wave represents the energy. So this is just kind of an artistic rendering. So what this means is that if you leave a particle in the cup for a while, the wave function will fill up the cup, and then it'll bleed out through the walls, and then you'll have a little tiny wave function at either side, which allows a small chance that the particle would somehow escape this potential, that it should have nowhere near enough energy to get through. And the higher the potential is, the sharper the cutoff. So it will be harder to escape a higher potential, but it never becomes quite impossible. So if the potential was much higher, you would get a sharper cutoff, but you still would see a little bit there. So let me draw that again. So now let's think about how this evolves over time. If you first put a particle in and you look at it, that is, you shine a ray of light and bounce a photon off of it, and then this goes back and you see it, that will determine the position of the particle at that specific time, and then as time evolves, the particle's position will get more and more uncertain. You'll never be able to pin it down precisely, so after a bit of time, its position might spread out a little, then it'll spread out more, and then more. We're not really going down in energy here, I'm just showing the time evolution. And then eventually it'll fill up on the sides of the cup, and then once it fills up the cup, it'll start pushing outside the cup and start filling out outside. So as time goes, first it'll fill outside a little, then it'll start filling outside a bit more and become more and more likely to have escaped. But let's go down in alternate history now. Let's say, instead of just looking at it once, we kept looking at it. So we have our particle there, and we looked at it. So we locked it into place, and then just an instant later, it spreads out a little bit. So the function is like that, and we look at it again. Maybe this time we find it over here. So it's locked into place over there, and then it spreads out again. We lock it into place again, spreads out, we lock it into place, spreads out, we lock it into place. And what happens this time is that by continually observing the particle, we never really give it a chance to spread its wave function out so far that it could plausibly be found outside of this potential. You know, there is a chance that it'll skip over, but the function cuts off rapidly at first, that it would have gone that far. And so as long as we're constantly observing it, we kind of lock it into place as behaving classically. It's only if we leave it unwatched for a long period of time that there's a chance it'll do something weird. We have to leave it in for a while, and then there's eventually a chance that the wave function will fill up the cup, and then we'll have a bit of decay, and then there'll be a not insignificant chance that it'll be found somewhere outside the cup. And then when we finally do look again, then we might see it outside. So this is why whether or not you're observing something in a quantum state matters, because when you're constantly observing it, you basically lock it down to it has to act like a classical particle, because in the short periods of time, it's really only probable that it will behave classically, but over a long period of time, it opens up more and more of a window for it to, skip over, not really care about this potential and be on the other side of it. You'll never catch it actually inside here. You can't resolve to find it caught within the wall, but you can find it outside the wall. Being caught would violate potential, but outside, the way quantum equations work, they just allow it, and this has been detected to be true. That's what happens in reality, that basically every particle is a wave, and the wave can leak through if you give it enough time. If you don't give it enough time, it can't really leak through significantly, so you lock it in. But otherwise, it'll build up how much is out and eventually become a significant probability that it has escaped. Okay, that's enough of that. Let's get back to the game. Alright, yeah, so a bunch of chat there. And of course, the difference with taking an image there is you only observe it once. You might as well just have a memory of where you saw it. You aren't locking it into place. In reality, you only lock it in if you take constant updated images of it. So here, however, if we take an image of the rock and keep looking at it, it stays in place. So this part doesn't align with how quantum mechanics works in reality. Okay, what's next here? The arch and the crystal do not naturally meet. So I guess what they're saying is, yeah, there's an arch there and a gravity crystal, and we would need them to be in the same place to go up. But yeah, just due to game design, they won't naturally be in the same place. So maybe what we have to do is lock one in, like lock in the crystal. Actually, I would prefer to lock in the arch because that's more likely to go out of sight. So we'll lock that in, and then we'll keep moving the crystal around until the crystal appears where the arch is. Yes, there we go. Okay, so that works. Okay, so the lesson they're giving us here... Ooh, yep. We lost sight of the crystal again while we were going up. Okay, so we're going to have to be a bit careful with that. So we're just going to have to go in a circle around it. There we go. Okay. Yep, plenty of shards here. Yep, big landing. Here we go. This is the last one, but we made it harder. Oh, so the Nomai are creating games for us, so... Is it? Okay, we've got 2 crystals on this wall. Okay, I think I see what we're going. Huh. Yeah, we only have 2 climbing crystals. Okay, there we go. That one's low enough now. So... we will take a picture of just this one to hold it in place until we can get the other one close enough that we can go up to it. Take a snapshot of that one. Okay, the other one's there. And we want the other one to be right above us. There we go. And then snapshot of that one. And we're out. Okay. Where do we go from here? There's the arch. Okay. Alright, what do we have here? This looks like... is that maybe the... Yeah, that's the same symbol we saw at the top, I think. And some Nomai and writing. We offer our congratulations. You've learned the rule of quantum imaging. Take this knowledge with you on the remainder of your quantum pilgrimage. Remember, the other quantum shards have other lessons to teach. Our curiosity goes with you on your journey. You walk in the footsteps of those who came before you, and your path guides those who will follow later. Okay. And we're back at the entrance here. Alright, so that looks like everything to learn there. And, well, now I'm curious why no one has been able to land on the quantum moon. it should be easy to keep the moon in sight while we land on it. I mean, it would be tricky that if you look away even briefly, it won't. But let's give that a go. So, signal scope, quantum fluctuations. So, yeah, there's plenty that's unknown. We'll have to figure out which of those might be the quantum moon, though. Oh, that's the tower shard. That's whatever is on the twins. Oh, yeah, there's the quantum moon, so we'll lock on to that. And let's try to very carefully land on it. If we switch to the landing camera, it's going to go out of our sight. So we'll have to land without aid of that, just keeping the surface of it always in view. It's an oddly smooth and uninteresting moon. Okay. Oh, okay, so it's got some cloud cover, that's why it appears so smooth. So we will keep facing it maybe until we're through the clouds, or if we go angled and then dip into the clouds. And okay, and it's gone. Okay, so maybe it's the cloud cover that when our view gets covered by the cloud cover, we can't see it. So, well, let's use what we learned here. And scout launcher. I don't think we can just take a picture, but yeah, we can. We've got an image like that, so will that hold it in place? Well, actually, we can just test. Oh, no, it did not. That's odd. Huh, I wonder why. Well, let's retrieve the scout, and then ship's computer. I think we can lock on to stuff from there. Yeah, so time should be paused right now, so let's just read up on what we found. Quantum growth. There is a strange rock shard in this grove that moves when I'm not watching. It emits a signal in the quantum fluctuations frequency. I found a poem written on one of the trees in the grove. Tower of Quantum Trials is the one we just did. So I guess there's Tower of Quantum Knowledge is different from the Tower of Quantum Trials. This tower held knowledge a Nomai needed to make his or her first quantum journey. Observing a quantum object, observing an image of a quantum object, these are the same. The Nomai called this the rule of quantum imaging. Remember, the other quantum shards have other lessons to teach. And yeah, there's still one unknown signal. And on the quantum shrine, yeah, we just got a bit more notes from Chirth, but I believe we go to it in map mode. Can we lock onto it there? No, it doesn't let us lock on. Okay, we'll have to search for it again. Maybe we can only lock on after we've been to a place. So, quantum fluctuations again. This time it's been identified, so it shouldn't be as hard. There we go. Quantum moon. Oh, it's by dark bramble. But when we get closer, we should be able to see it apart from dark bramble. Okay, so we want the scout launcher. And so it's kind of odd that the quantum imaging didn't seem to work on the moon when we got a picture of it with the scout launcher. But okay, let's change our lock on to the moon and autopilot to that. Yeah, and then we will... Okay, try to get to the moon, not Dark Bramble itself. Maybe if we put the... Oh, that's interesting. So we get static from the scout. So I guess it can't go through, but... Okay, we got a nice clean image of it. And if we go to... Oh, because when we go to our landing camera, the moon is out of view. Oh, that's it. So not just the moon is out of view, but the image of the moon is out of view. Okay. The sun is exploding, but we'll just have to go without the landing camera here. And do a... Okay, that was Giant's Deep, not the quantum moon. It just looked different because we were on the other side of it. Oh, okay. So the quantum moon is going to be an ordeal. Let's see if we can quickly find it again. Yeah, it could well be too late now. That's the island shard. Other stuff is way over here. Okay, Yeah, we have to go specifically to the moon, not one of the other ones. Or we could just watch the sun explode. That could be fun, too. Oh, that's actually quite beautiful. Yeah, if you're gonna die, that's the way to go. In a beautiful supernova that... Really, it takes you out before you even know you're gone. At least it would in reality, and in-game it's a bit slower. Okay, and we're off again. Well, actually, I should correct myself. The supernova here is actually a lot faster than it would be in reality. Real-life supernovas are indeed some of the fastest cosmic events we see in the universe, but they're actually still a lot slower than we see in the game, just due to the vastness of space is why it's slower, because there's so much more space to cover. Although the rate things are actually moving is still a lot faster, so it'd still envelop you really before you know what's going on. Okay, there's the quantum moon. Okay, so let's head off that way. We'll try to land again. So, if you want an idea of how fast a supernova is, it's, it varies a bit depending on the type of the supernova. There are actually two very distinct types of supernovas, and then plenty of subtypes. But roughly speaking, a supernova takes about 2 weeks, which really, for things happening out in space, is lightning fast. Not quite as fast as lightning. Lightning is basically the speed of light, but... Okay, there's a good image of it. But yeah, supernova is, it's an appreciable fraction of the speed of light, but not quite the speed of light. Oh! Well, we gotta... Okay, so yeah, we're keeping the image in sight. But yeah, very light gravity on the moon, so we're going to need to be delicate here and try not to crash into the ground. Okay. Alright, and then we settle down. There we go. Now, hopefully, the fact that we're standing on his ship, which is resting on the planet, counts as enough of an observation that it's not going to vanish on us. So, so it's watery. Okay, interesting. And, okay, so we need the shrine to be at the north end of the planet, or the moon, sorry, to get off. to get to the 6th location. Okay, so the shrine is here. Does that... Yes, that shrine does move on us. Okay. Well, let's see. Can we get to the north side of the planet here? And... Okay, yeah, so... Huh. Oh, that's interesting. This is just like on Giant's Deep itself. We've got a big cyclone at the north side. Okay, so... It's not going to be that easy. We've got to find some other way to get to the top. To the north. Okay. Here's the shrine again. Let's go inside. See what's going on. Okay. So, what do we have here? That's the shrine. I'm not really sure what that is. It looks like stalactites, so maybe somewhere we haven't explored looks like that. Okay, I think that's showing the tower that's on Brittle Hollow. Oh, wait, maybe that isn't this shrine. Maybe that's the tower we found on Giant's Deep. So... Maybe... So those are the 2 towers and something else I don't recognize. So maybe it's telling me I should go there for information. But let's just play around here first. Okay, we've got this, which lights up that. That's interesting. Oh, there's something on the wall when I did that. Okay, so turn it on again. Recall the rule of the 6th location. You have recalled the rule of quantum imaging. So I guess probably because we have to use quantum imaging to get here at all. And then recall the rule of quantum entanglement. So we haven't learned that rule. I'm not sure if it'll have anything to do with real-world quantum entanglement, which is... Well, it basically, real-world quantum entanglement says that, like, if you produce 2 particles where, for instance, some conservation law limits how they'll both behave, like, let's say you have a process that is going to spawn 2 particles splitting off from each other in a random direction. By quantum momentum, by conservation momentum, if the initial momentum is 0, the 2 particles will have to go in opposite directions. So, although the direction of either one of them is essentially random and could be anywhere, if you find where one of them is, you know where the other one is. So, basically, you say those 2 particles are entangled because their wave functions are really the same wave function, in a sense. That if you track down where one is, you know where the other is. It collapses from a wave to a defined point. I'm not sure how that helps us, though. How would we set something up like that? And what else is going on here? Okay. Okay, so these are the diagrams of the various planets again. Twins, Timber Hearth, Brittle Hollow, Giant's Deep, Dark Bramble, Eye of the Universe. This is the Quantum Moon. Okay, it was near Giant's Deep when we got here. And yeah, so that says the moon is on Giant's Deep. So I guess this is a tracker. And if we had arrived when it was around one of the other planets, it would be somewhere else. Okay. Well, I'm not seeing much else to do here, but it does tell us, recall the rule of quantum entanglement. So, I think we're going to have to learn that before we do anything else. But right now, I just want to jump into the cyclone to see what happens. Ah, okay, it's pushing me away. Okay, no fun with the cyclone. Okay, so we can't get to the North Pole here, that's too bad. Well... in that case, I think I am going to call it
much
here
for watching, everyone. If you enjoyed this video, please leave a like, subscribe, and click the bell to be sure you get notifications of new
for
uploads.
joining me for
See
all
you
the
again
quantum weirdness today, and I hope you all will be back next week for the next episode. See you all then. Bye-bye.